here we go. All right, so we're going to look at section 9-5. It's called the binomial theorem, which must mean that it deals with binomials, right? So some basic facts that I have here. The number of terms in your final answer is one more than the power. So if you think about it this way, when we have a quadratic, if it's a perfect square trinomial, quadratic is something to the second power, highest degree of second power, right? So if we have a perfect square trinomial, what is it raised to? A binomial to what power? To the squared. If you multiply that out properly, how many terms do you have? If you FOIL it, how many terms do you have? Not 2. 3. Come on, guys. Right? Well, just to prove to you, so if I had, x plus 2 squared, right? Isn't that x plus 2 times x plus 2? And if I distribute, x times x is x squared. X times 2 is 2x. 2 times x is 2x, and 2 times 2 is 4. But those two combine, don't they? And you end up with x squared plus 4x plus 4. So I started with a power that's squared, and I ended up with 3 terms. 1 term more than what my power was. That's what that's saying. The number of terms in that final answer is 1 more than the power. So if I have something raised to the 8th power, how many terms should I have? 9. So that's an important fact that you might want to remember, because it's going to enable you to determine how many things you're looking for. So all of these are important. Then your first variable always starts with the power of the binomial and decreases by 1 until equal to 0. We'll look at this one. Here's the power of my binomial, right? It's 2, and don't I go 2, 1? Isn't this constant x to the 0? What's x to the 0? 1. So it goes 3, 2, 1. Then it says the second variable will start with a power of 0 and increase up by 1. Well, the second variable is this one. It's your constant. So what they're saying is that constant, it starts here with 0 and goes 0, 1, 2. Well, what's 2 squared? 4. You'll see how that works in a minute. Then the sum of the variables equals the power on the binomial. We'll have to look at that later, not with this particular one. And that one I don't necessarily use all that much, but the sum of the variables equals the power on the binomial. We'll see how that works in here in a minute. So you might want to put a little star on this one. Coefficients on the terms increase then decrease in symmetrical order. Again, you're going to see that as we do this in a minute. It's not going to show very well on this one. So you might want to start this one. You'll see that one shortly. And then this is a nice little formula. To find a coefficient, you're going to take n factorial. What does this mean? C. Combination. Isn't this your combination formula? N factorial over the difference of these two factorial, and then this one factorial. And it's going to equal n over m. We'll talk about this notation in a minute, because we have it down here on these two, right? We'll talk about that in a minute. All right, so just remember that. So here we go. The binomial theorem looks like this, and it's kind of ugly. I don't expect you to memorize that, because I'm going to show you an easier way to do that. So that's x plus y to the n. So here's how we're going to expand it. So if we've got x plus y to the 4th, how many terms am I going to have, according to what we saw above? 5. So I'm going to put 1, 2, 3, 4, 5 blanks, because I know I'm going to have 5 terms. And I'm going to show you a much easier way to find your coefficients than what you'll see here. And in fact, I'm just going to jump to it right now. So, because I don't want to have to show you the hard way. So let's just jump and flip to the back so I can show you how we're going to find our coefficients. So Pascal's triangle, it's a beautiful thing. It's like a human calculator. You could have an entire course in Pascal's triangle and use nothing but Pascal's triangle. It's just fascinating. If you take 2 and raise it to the powers, you'll see that the sum of these rows equals 2 to its various powers. What's 2 to the 0 power? That's the sum of row 1. This is called row 0, by the way. Notice that this right here has a power of 0. What's 2 to the first power? What's 1 plus 1? 2. What's 2 to the second power? 4. What's 1 plus 2 plus 1? 4. I'll do one more. What's 2 to the third power? 8. What's 1 plus 3 plus 3 plus 1? 8. So if I wanted to find out what 2 to the 10th power was, I'd find the 10th row of Pascal's triangle. I could add them up and that would tell me what it is. So it works with 2 quite well. If you look at the second number, obviously each row starts and ends in 1. You see that pattern, right? How did they get the 3 here or the 4 there? Or the 10 here? You add the 2 that came above it, right? So this 2 comes from adding those 1s together. This 3 comes from adding the 1 and the 2 together. So if we're to find, and in fact I'm going to put a little pencil mark on here. Can you hand me that ruler? Thank you. So I'm going to put a little pencil mark on here so I can get my row in here straight, because that would drive me crazy. All right, so I want you to come up with row 6 and row 7 of Pascal's triangle. Notice that if this is row 0, there's nothing over here, correct? If this is row 1, what's the second number? A 1. If this is row 2, what's the second number? 2, 3, 4, 5. So you see a pattern going along on this diagonal, right? That same pattern goes along that diagonal too. This is a very symmetrical thing. If I put my pencil right here, doesn't the left half look like the right half? This middle row right here where my pencil is at is different, and you'll probably see a pattern going there as well. So go ahead and finish that up. When you do your homework tonight, you might have to expand this to the 8th, the 9th, or the 10th row. You probably won't have to go much further than that in your homework, only because it'd be a little hard to fit. Like, if you had to expand something to the 20th power on your paper, it would be a little hard to fit, wouldn't it?
Do we have to put all the rows, or can we skip a couple rows?
Oh, you only have to put one row. So here's my point. Here's how you find your coefficients for your expansion. We are working on this one on the front, right? X plus y to the 4th. I want to find the 4th row of Pascal's triangle. You will start to memorize that row of Pascal's triangle. You'll start to memorize the first few rows of Pascal's triangle because you're going to use them over and over again. And the 4th power is a very common one. So if I find the 4th row, here's my 4 right here. Isn't the pattern 1, 4, 6, 1, 4, 6, 4, 1? Those are the coefficients of my 5 terms. Aren't there 5 things in that row? So if I'm raising something to the 5th power, I'm going to use the 5th row of Pascal's triangle as my coefficients. If I'm going to raise it to the 6th, I'm going to use the 6th row. Okay? And then if I want you to find something that's, if we're expanding something to the 20th power, and I only want you to find a specific term in there, I'll show you how to find the coefficient using a different formula so you don't have to take Pascal's triangle all the way out to the 20th row, which would be excruciating. But you could Google it and look it up, I'm sure. But I wouldn't make you do that. All right, so our coefficients, and this is where I got them, was from Pascal's triangle, are 1, 4, 6, 4, and 1. That's directly from Pascal's triangle. Then the second thing, our basic facts, says the first variable starts with the power of the binomial and decreases by 1 until the power equals 0. So I'm going to take a different color. And isn't my first variable here x? So then I'm going to multiply this by x to the power of my binomial is 4. So this becomes x to the 4th times x to the 3rd times x squared times x. And I'm not going to make you put times x to the 0. I find that confusing. But wouldn't that be x to the 0? Then we're going to go backwards and do it the same way, but go backwards. Then this one says the second variable starts with the power of 0 and increases. So you could either start here at 0 or you could start back here at the power of 4. I like to work backwards, honestly. So I'm going to take my second variable here, which is y, and I'm going to put times y to the 4th and work my way backwards this way. Times y to the 3rd, times y to the 2nd, times y to the 1st, and then this would be times y to the 0. I don't find a reason to put it in there. You'll make more mistakes than necessary. And if I were actually to multiply those out, we don't have any multiplying to do other than, wouldn't my first term be x to the 4th? Oh, and we'll talk about signs here shortly. But let's just put in plus signs here for right now. So without having, now I could have taken x plus y times x plus y, right, and multiplied that together. And I could have taken the same, I get the same thing if I took x plus y times x plus y and multiplied that together. So that's my x plus y squared I've multiplied together. Then I can multiply those trinomials together, and I would get this. Wasn't that a lot less work? If you understand the pattern. Was there anything hard about that? Yes or no? No. We'll do more of that in a minute. Let's go ahead and find binomial coefficients. We use combinations to do that, or, I mean, I've obviously showed you Pascal's triangle, but we also use combinations. So let's just go through and talk about combinations in a minute. We could use this whole thing right here, and then we're gonna, right here, and then we're gonna talk about what's a shortcut. So if I'm gonna find the combination of 8 items taken 2 at a time, the pattern would be, I can't even read those numbers, would be 8 factorial, would it not? Over 8 minus 2 factorial times 2 factorial, right? And if I were to have to write all this out without my calculator, it would be 8, 7, 6, 5, 4, 3, 2, 1. And I want you to think about what's a shortcut that we could use instead. If I were to write this out, this would be 6 factorial here. So this would be 6, 5, 4, 3, 2, 1. And then 2 factorial is 2, 1. Does anybody not understand what I just wrote there and why? Okay, look at what cancels and what's left. Everything in the denominator should cancel. If you have something left in your denominator, you did something wrong. Wouldn't those 2 cancel with those 2? Right? And wouldn't 6, 5, 4, 3, the 6, 5, 4, 3, doesn't that cancel there? All I have left is a 2 on this particular one. The 2 would cancel into the 8 how many times? Yeah. But look at what you have here. You have 8, oh, here's what we have left. 8, 7, and then we really have a 2. I don't have to really talk about the 1. If I had just started with that and knew that that's what I'd always be left with, life would be so much happier. I wouldn't have to write all that out. Notice what this number is here too. How many numbers of 8 factorial do I have here? 2. Notice what this number is here. A 2. It's that one right there. We're going to test it on, well, I can't test on that one. We'll test on another one in a minute, but trust me that the shortcut would be to just write 8 times 7, only 2 of those, over this factorial, 2 times 1. And then all I'd have to do is just go, oh, 2 goes in here once, and in here 8, 4 times. So my answer should be what? 14. Oh, gosh, where did I get that? I don't even know how I got 14. Sorry, 28. 4 times 7. That was a good one. Did you mark that down, Kelsey?
How do you find it?
Because you're always tallying my errors. All right, so then this notation right here just means a combination of 10 items taken 3 at a time. It's just a different way of writing it. So again, I could write 10 factorial over 10 minus 3 factorial times 3 factorial. And I'd have, in fact, I'm going to do it on the board. Don't do it on your paper, but I'm going to do it on the board so we can kind of evaluate what the shortcut is. Here's my blue. So if I did 10 factorial, wouldn't that be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, right? Over 10 minus 3 factorial would be 7, 6, 5, 4, 3, 2, 1, and then 3 factorial, 3, 2, 1. Tell me if what we talked about works on this one just like it did on that one. The 3, 2, 1s cancel, don't they? And then I have 7, 6, 5, 4. That'll cancel with 7, 6, 5, 4, bless you. What are you left with here and here? What number is here? 3. So can I take a shortcut and say I'm going to take 3 factorials of the 10, 10, 9, 8, and put the 3 factorial down here? I like the shortcut. If you don't like the shortcut, you want to do it the long way, by all means do it the long way. But there are some problems you're going to appreciate the shortcut on. So I'm going to erase this and put the shortcut up. Is that all right? Some of you are writing madly. Can I erase it? Okay. All right, so instead, I would prefer the shortcut of 3 of these 10. So 10, 9, 8 over 3 factorial. 3, 2, 1. So now all I have to do is cancel 3 into the 9 3 times, and 2 into either the 10 or the 8, doesn't matter which, I'm going to cancel into the 10, and then multiply what's left over. Come on. 3 times 8 is 24. What's 24 times 5? What is it? You're right, 120. Now, do you remember how to do this on your calculator? Have I shown you that yet? Okay. So remember, you're going to go to your calculator. I'm going to pull out of my screen here. Where do you find your combination button? Under where? Which is under what? Math. So go to your probability tab under maths, and then you see number 3 is C. Now, depending upon what calculator you have, if you have the older ones that I use in class, you have to put the 10 first. If you have the newer calculator, like most of you do here, sitting here, I can put them in, and I think, let me see, I think I might have to put my 10 first. Yep. All right, so never mind, 10 first, and then math, 3, and then I can put in my 3. So the old and the new work the same way. What do we get? 120. So you can verify those ones on your calculator. You're still going to have to show them by hand on your test. Show that you understand what your calculator is doing. But there's some hard... Yeah, there's... Right, just like I showed here, you can show the shortcut. Then we need to talk about this. This one, where did my red pen go? It's very important I have my red pen. Aha. These two right here, you can use a shortcut on. A and B. But you cannot use a shortcut on this one. You can't use shortcut. And the reason why you can't use a shortcut is when two different situations. When either you have when R is equal to 0 or when C is equal to R. The C is never going to be 0. But if R is 0 or C and R are exactly the same, which they are in those cases, you can't use your shortcut. So we have to do these the long way. So this would be 7 factorial over 7 minus 0 factorial, and then 0 factorial. Do you know what 0 factorial equals? 1. And so we have 7, 6, 5, 4, 3, 2, 1 over 7, 6, 5, 4, 3, 2, 1 times 1. Huh. What happens? All of that cancels and all of that cancels. And isn't your answer equal to 1? Now these are giving you coefficients, by the way. So then let's look what happens here. Here you really have a combination of 9 items taken 9 at a time. So that would be 9 factorial over 9 minus 9 factorial, 9 factorial. Well, isn't this 0 factorial, right? Which has a value of what? 1. Do I have to write these out? Can't I cancel a 9 factorial with a 9 factorial? I mean, we just proved here that it's going to work, right? So isn't this also a value of 1? So let's expand these binomials. You have to write small. So I do one more. Oh, there we go, one click. All right, so how many terms am I going to have for A? 5. 1, 2, 3, 4, 5. And then, do you remember the coefficients from before? It's the 4th row of Pascal's triangle. Isn't it 1, 4, 6, 4, 1? That 4th row of Pascal's triangle. We just used it above, right? And then start with your first variable, or the first thing in your binomial is an x. So I'm going to take that, and it goes to my power of my binomial. So I'm going to take x to the 4th. So x to the 4th, then this is x to the 3rd, x to the 2nd, x to the 1st, and then this would be x to the 0. Now this one is different than the one above example 1, because this is not a variable, it's a number, isn't it? You still do the same thing. I'm going to start here at the far end, and I'm going to take the 3 to the 4th power. So this becomes 3 to the 4th, go backwards, 3 to the 3rd, 3 to the 2nd, 3 to the 1st, and this would be 3 to the 0. Then we have to multiply everything out. So this, and by the way, when there's an addition here, these are all addition signs in here. We'll talk about when it's subtraction like this one is over here. So this one becomes x to the 4th plus, what's 4 times 3? 12. So I get 12x cubed, right? And then what's 3 squared? 9. 9 times 6. So this is 54x squared. And then what's 3 cubed? 27. 27 times 4 is 108. X. And then what's 3 to the 4th? 81. So plus 81. We did all of that without that dreaded foiling or distributions, right? You see why I kind of like this? It saves you out a lot of work. Lots of work. All right, so let's explore what happens when you have a negative and then we have an I here. What's an I again? Imaginary number. So let's write ourselves a couple of notes. First of all, I have a negative here, which is a little different. When there's a negative, you are to alternate signs starting with a negative. So when it's addition, we're not alternating signs at all, but when we have subtraction, we will alternate signs, always start with a negative. And then the other thing I want to remind you of is that I is equal to what? Square root of what? Negative 1. What's I squared? Negative 1. What's I cubed? Negative square root of negative 1. Or, really, most importantly, isn't it negative I? Right? And then what would be I to the 4th? What's this squared? Positive 1. And it starts all over again with I to the 5, I to the 5th. I to the 5th would just be these two multiplied, right? So I to the 5th would just be I, wouldn't it? And it goes on from there. All right, so if I'm to the 5th power, how many terms am I going to have? 6. So let's write really small. 1, 2, 3, 4, 5, 6. And we have to alternate signs. So I'm going to put in here in green, I guess. I'm going to start with a negative, a positive, a negative, a positive, and a negative. Then go to the 5th row of Pascal's triangle. If you know the 4th row, you can create the 5th row from your brain, right? But here's your 5th row of Pascal's triangle. Whoops. 1, 5, 10, 10, 5, 1. And that's another one that you're going to get comfortable with because you're going to use it a lot. Yes?
How did you know how to, I know that when you have a negative, or when you minus sign, you use alternate signs, how do you know which one's wrong?
You always start with a negative. So did you write that there, that we're always going to start with a negative?
No.
Okay. That we just will. Because we've, meaning not you and I, but we've, higher beings of mathematicians, that really doesn't include me. I've noticed the pattern. They will always start with negative. All right, so I've got 1 here, 5, 10, 10, 5, and a 1. That comes directly from Pascal's triangle. And then I'm going to take my first term here as a 2. So I'm going to take 2 to the 5th power, 2 to the 4th power, 2 to the 3rd power, to the 2nd, to the 1st, and then no 2. Then I'm going to start here on the right-hand side with I, not a negative I, just an I. So this becomes I to the 5th, I to the 4th, I to the 3rd, I to the 2nd, and I. And because we have an I to the 5th, I am going to write I to the 5th out here. I to the 5th. Remember, it's I to the 4th, which is 1, times this. Wouldn't this just be an I? Right? So I to the 5th is actually equal to I. That's going to help us in a minute. What's 2 to the 5th? 32. So we've got 32 minus, what's 2 to the 4th? 16. What's 16 times 5? I'll help you out. Is 80. We have 80I. And then 2 to the 3rd? 8 times 10 plus 80 I squared. We'll deal with the i's in a minute. And then 2 squared is 4 times 10 is negative 40 I cubed. And then 2 times 5 is 10 I to the 4th minus I to the 5th. Now we have to take care of all of our i's because i's simplify. So we're not going to deal with, we can leave it as an I, right? So we've got 32 minus 80I, that doesn't change, but I squared is what? A negative 1. So a negative 1 times 80 changes the sign, right? So, and this becomes a negative 1, so it's just minus 80, isn't it? And then, what's I cubed? A negative I. So it changes this sign, so it becomes a positive 40I. And then I to the 4th, we said was 1, so this just becomes plus 10. And then not minus yet. I to the 5th is 1, because that's I to the 4th times I is I to the 5th. So 1 times, we're not going to write square root of negative 1, we're going to write I. So I to the fifth, it just becomes minus I. And then we can combine like terms, can't we? We've got the 32, the 80, and the 10. And all of that combines to give you negative 38. And then we've got all these i's. Negative 80i, positive 40i, and negative I gives us negative 39i. That's our final answer. So even though this one doesn't have a final answer of 6 terms, it's because the i's converted them. All right, so then flip it. I will talk about this one if I get time, but let's look at this right here. So let's skip to example 4. So for example 4, we're going to use find the coefficient a of the given term something x to the 8th. In the expansion of the binomial, we have a binomial to the 12th power. So watch how the 8 and the 12 play around here. So we're going to start with a is going to equal combination of n items taken r at a time, this is your n, I didn't write that very well, times x to the r, I'll tell you what n and r are in a minute, times 3 to the n minus r. So n minus r, well first of all, isn't this n? Because it's our power of our binomial, the bigger number's n. And then this is our r. So n minus r is 12 minus 8, which is 4. Oh, well, I take that back. This is not our r. I lied to you. Your r is this. It's n minus r is actually equal to our 8. Did I say that right? No, yes. So erase this for a minute. Well, I was trying to think of what I wanted to write there, and I didn't write that correctly. So that I want it to be, we'll call this O question mark. Make that a question mark. And this right here is your question mark. So I don't really have a name for that. So this is going to be my question mark right there that I put there. So I know that my power to my binomial is 12. I do need to find r. I do know that because this could change. I could ask for the 7th term, I could ask for the 6th term. So what would r be? 12 minus what is 8? 4. So your r has to be 4. Okay? So this is still r here. Now, we're going to find our a. So plug in what we know. A is equal to c, n times, that's our 12. Our r we just found was 4, right? Times x to the, our question mark, wasn't it 8? Because we know the exponent of our x is 8, because they gave that to us, right? And then times, oh, where did I get the 3? I didn't tell you that part. Where did the 3 come from? Look at your binomial. The 3 came from there. I know I'm trying to hurry. My fault, sorry. And so times the 3 from this binomial raised to, what's your, and I'll finish this tomorrow. So do as much of your homework as you can. If you come across this one, hold off on it and we'll talk about it tomorrow.